You're welcome to Educational World. In today's video, we'll be looking at a typical practical on friction. And let's look at the question. You are provided with a wooden block to which a hook is fixed, a set of masses, spring balance, and other necessary materials. Using the diagram above as a guide, carry out the following instructions. Record the mass MO indicated on the wooden block. Place the block on the table and attach the spring balance to the hook. Pull the spring balance horizontally with a gradual increase in force until the block just starts to move. Record the spring balance reading F. Repeat the procedure by placing in turn masses of M equal to 200, 400, 600, and 800 grams in the block on top of the block. And in each case, read and record the corresponding value of F. Evaluate M, capital M, equal to MO plus N, and R equal to capital M over 100. Tabulate your readings. Plot the graph of F on the vertical axis and R on the horizontal axis, and also determine the slope of the graph. So you are going to look into the background of the question. What are the things you're supposed to know before you can be able to tackle or outsmart this practical? Now, for us to be able to outsmart this practical, we have to first determine what this practical is all about. Okay? Now, the aim of this practical is to help us determine the coefficient of friction between the block and the surface. Now, recall that mu is equal to the frictional force all over the weight or the reaction of the body. Mu is the coefficient of friction, and R is the reaction or the weight of the body. So we're using this for the rest of this practical. So let's look at the procedure. What are the procedures to be followed in order for us to outsmart this practical? So the first thing we have to do is to record the mass of the wooden block, which is M subscript O, and I have gotten my mass to be 477.50 grams. Now, after that, we have to perform the first experiment by gradually applying a horizontal force until the block just starts to move. And when that happens, the value of the force on the value of the reading of the spring balance is recorded as F. And let us say we've performed it and we have our value of F to be 1.20 Newton. Now we compute our table of values. We have that when M subscript O is 477.5 grams, the mass on top of the block is still 0. Now the capital M is 477.5. The reaction here now is 4.7750 Newton, and the applied horizontal force is 1.20 Newton. Now, using our formula that says that the coefficient of friction is equal to frictional force over the reaction, and inputting the values where necessary, we now find that the coefficient of friction is 0.251. So this is the value of the coefficient of friction, and we'll be using it for the rest of this practical. So when we now add a mass of 200 grams on top of the wooden block, okay, now the total mass now becomes 677.5 grams, and the reaction becomes 6.775 Newton. Okay, very, very interesting. So with this in mind now, we can be able to compute, can be able to derive the value for the frictional force by using the formula coefficient of friction is equal to frictional force over reaction. And inputting the values where necessary, we will now see that the value of the new frictional force will be 1.7 Newton. And if we compute our table of values, we will now have that when the total mass is 677.5 grams, the frictional force is 1.7 Newton. This is very, very interesting. Okay, so we are going to move ahead. Now, using this procedure, we can be able to get other values as required. Okay, from our table of values, we now see that when the total mass is 877.50 grams, what will be the frictional force? Don't forget the formula for the coefficient of friction. So frictional force is equal to the coefficient of friction times what the reaction. And if we do that, we have our value to be what? 2.0 Newton when the total mass is 877.5 grams. So when the total mass is now 1077.5 grams, what will be the frictional force? In the same way, frictional force will be the coefficient of friction, which is what? 0.251 times 10.775 grams. And the new value for the frictional force will now be what? 2.7 Newton. So in the same way, we can now find the value of the frictional force when the total mass is 1277.5 grams. Using the same procedure or the same formula, frictional force is equal to coefficient of friction times the reaction. Now the new frictional force is what? 3.20 Newton. So that's all for the procedure. We now move over to the graph plotting. Now concerning the graph plotting, we bring out the values that are required for us to be able to plot our graph. Now you can see that our table of values had uniform decimal number of places, which is very, very important. So this is the graph of F against R. So we choose our scale to be 2 cm to represent 1.6 units on the x-axis, and also 2 cm to represent 0.4 units on the y-axis. Actually, I'm not teaching on how to plot graphs and find scale here. I will do that in subsequent videos. So when we plot the points, we find that it's a straight line graph. And for us to find our slope, we choose convenient points on the graph and draw out a right angle triangle from there. And from there, we read up our values. Okay? We read up our values to the axis. So the slope here now will be change in the vertical axis all over change in the horizontal axis, which is change in F all over change in the reaction R, and with the two values we have 2.7 minus 1.7 all over 10.76 minus 6.76. So that gives us to be the slope is now what? 0.25, which is similar to what we have as our coefficient of friction. Now the slope here has no unit. Okay, so that is all about this practical. If you find this practical informative, I would like you to hit the subscribe button there, like and share, recommend to your friends. Thank you once again for watching. I once again remain grateful. Have a wonderful day.